In today's video, we're going to look at section 8-3, graphing rational functions. So a lot of information in this video, so please pay attention. A rational function, it has a few things. It has the form of p of x divided by q of x, where p of x and q of x are polynomial functions. And q of x cannot equal 0 because obviously the denominator in a fraction cannot be 0. So here's some examples. F of x equals x over x plus 3, g of x equals 5 over x minus 6, and h of x equals x plus 4 over x minus 1 times x plus 4. So in these situations, we got to describe when we cannot have, what variables we cannot, or values we cannot have for the variables, such as the first one. X cannot equal -3 as the bottom will become 0. The second one, x cannot be equal to 6 because that would make the bottom 0. And the last one, x cannot be 1 or x cannot be -4 because both those terms values will make the bottom 0. So we got to look for those numbers. Now that creates asymptotes. Okay, if the rational expression of a function is written in the simplest form and the function is undefined for x equals a, then the line x equals a is a vertical asymptote, meaning the bottom. Okay, whatever would make the bottom 0 would give us a vertical asymptote. So for x over x minus 3, x equals 3 is the vertical asymptote because it would make the bottom 0. So x cannot become that value. Point of discontinuity is a hole in the graph or a break in the graph. This is when you have something that makes the bottom 0, but it gets canceled out. Okay, so notice in this we have an x plus 2, x plus 2. Okay, these would actually cancel each other out and leave us with x minus 1, which is just the line. But we still can't have x equals 2 because we got or -2 because we got to look at the original bottom, and that -2 is right here, but since it cancels out to just down a line, it's just this one point down here. So we always have to look for the original to find where our asymptotes and our breaks are. Okay, so determine the equations of any vertical asymptotes and the values of x for any holes in the graph of f of x equals x squared minus 1 times over the quantity x squared minus 6x plus 5. I'm struggling here. So we got to factor a little bit. So f of x is equal to x plus 1 times x minus 1. And then on the bottom, we have x minus 1 times x minus 5. So then, well, the ones that are going to cancel out are going to be your holes, and the ones that are left are going to be your asymptotes. So our asymptote, so our vertical asymptote, is whatever makes the first of this one 0. So our vertical asymptote is the equation x equals 5. Okay, that's what it means. So x equals 5. And then our hole in the graph is when x is 1, when x is 1. Okay, because that's what would make x minus 1 0, but it's going to end up canceling out. So we're actually going to be left with the function x plus 1 over x minus 5. So you always got to find those first, then you can do your simplification and canceling out. Okay, reducing. So horizontal asymptotes is kind of important. When the degree of a numerator is greater than the denominator, then there's no horizontal asymptotes. Okay, so notice the degree we're talking about is the degree of the biggest exponent. Okay, so the top is 2, the bottom is 1. That means there is no horizontal asymptotes. Okay. When the degree of the numerator and denominator is the same, the horizontal asymptote is the coefficients of the highest degree. So in this one, we actually have 1x squared minus 1 over 2x squared minus 3. So we look at the coefficients of the highest degrees, and so our horizontal asymptote would be at y equals, let's make that a little bit better, y equals 1/2, 1/2. Okay, and then when the degree of the numerator is less than the denominator, the horizontal asymptote is x equals 0. Okay, so in this case it's just 5, and the bottom is x squared minus 1, so our horizontal asymptote is x equals 0. All right, so graph f of x equals x over x minus 2. So here we can see the vertical asymptote, since we can't do any reductions, would be at x equals 2. So I'm going to draw my x equals 2 vertical asymptote. Okay, and now I'm going to find my horizontal asymptote. So in this case, the horizontal asymptotes, we both have a degree of 1 and a degree of 1, so we are left with x equals, we just look at the coefficients, 1, 1, so it's just x equals 1. So, or excuse me, y equals 1, that's my fault. It should be a y equals 1. So I'm going, oh, it should be a dotted line. Okay, so now I'm just going to make a quick chart and pick a few numbers to kind of give a visual of where it's going to be. So if I take x and y and plug in, I'm going to start with -2. If I plug in -2, that would give me 1/2. If I plug in -1, I get 1/3. If I plug in 0, I get 0. If I plug in 1, I get -1. If I plug in 3, I get 3. Okay? And if I plug in 4, I would get 2. All right, so now I think that's good for now because it's going to kind of trail off. So I'm just going to graph these points. So -2, and I get 1/2. -2, 1/2. So it's about right there, a little bit higher than that. There we go. It's a little better. And I get -1, and I get 1/3, so right about there. And then I get 0, 0. You can't really see it. There we go. And then I have 1, -1, 3, 3. So I get 3 and 3. There we go. And 4, 2. Okay, and so what actually happens is what these graphs do is they kind of trail down the asymptotes. It's kind of neat what happens. And I got all my numbers from my calculator, so please feel free to do that. And then same thing, it's going to trail down the asymptotes and extend off. Okay, and if you want, plug in your calculator, double check it. All right, so now let's do another one. Graph f of x equals x squared minus 9 over x plus 3. So I need another graph. There we go. Okay, so here, once again, now we look at our vertical asymptotes. Okay, well, first we got to factor a little bit. So x plus 3, x minus 3. And notice the x plus 3's will cancel out. So actually, there's not going to be a vertical asymptote. It's going to be just a hole. So there's going to be a hole at x equals -3. So then what happens is they cancel out. X plus 3's will actually cancel out. There's going to be no vertical or horizontal asymptote because the numerator degree is bigger. So no vertical, no horizontal asymptote. And so now I'm just left with f of x is equal to x minus 3. Well, that is just a simple line. So go to -3. Okay. And then up 1 over 1. And so remember, there is actually a hole at -3. So there we go. Or excuse me, at x equals -3. Sorry, that's a mistake on my part. I got ahead of myself. It's actually at -3. So when I plug in, so at -3, wherever the line crosses, so wherever, I'm just going to draw a little line right there. Okay, so here we go. Right there is my hole. And I continue my line. And there we go. Okay, so that's how it will end up looking.